going to switch gears a little bit in today's lesson and start to talk about equations that have two variables rather than equations that have one variable. And in this lesson, we are also going to be focusing on doing a little bit of graphing as well. So I want to start by introducing you to something called the rectangular coordinate system. And that's what I have drawn to the right of the screen. This is how we're going to plot information with two variables. The horizontal axis is the x-axis, the vertical axis is the y-axis. And then the idea is we can plot information in this coordinate system. For example, if we look at point 1a, that point 0,3 is referred to as an ordered pair because the order of the numbers is actually important. The first number is always the x, so this is saying x equals 0, and the second number is always the y value, y equals 3. To plot this on my coordinate system, I would start by looking at the horizontal axes and finding x equals 0. That's in the center or the origin, so right here is where x equals 0. Then, because y equals 3, I'm going to go up to 3 on the y-axis. So in blue, I have plotted the point 0, 3. In part B, we have the point -1, -4. So x is -1, so horizontal axes, I go over to the left now to -1. And because y is -4, I'm going to go down 4. And there in green is the point -1, -4. Part C, we have the point x equals 1, y equals 1/2. So now I go over to the right 1. And then for y equals 1/2, I'm just going to have to estimate and go about halfway up. And so in red is part C, the point 1, 1/2. My last point is x equals -3.5 and y equals 2. Once again, I'm going to have to estimate where is -3.5, somewhere between -3 and 4. And then y equals 2 means I have to go up 2. So the idea is information in two-dimensional space can be graphed on this coordinate system, and we can describe information in two-dimensional space using two variables, an x and a y value. Now going back to the idea of equations, here's an example of an equation with two variables, 2x plus y equals 4. Equations that have two variables have many solutions. If we want to determine if an ordered pair is a solution, we have to plug it in and see if we get a true statement. This is very similar to what we did when we had equations with one variable. So in part A, that ordered pair is telling me that x equals 2 and y equals 0. So I'm going to take the equation above and I'm going to replace the x with 2 and the y value with 0. And then if I do the math, I notice I get a true statement, 4 equals 4. And so yes, this point is a solution to this equation because it works out. Whereas in part B, this ordered pair is x equals 1, y equals 1. So I can replace the x with 1 and the y with 1. And this time when I do the math, I end up getting a false statement. 3 does not equal 4. And so that indicates that this point is not a solution. My last ordered pair, x equals 3, so I plug 3 in for x. Y equals -2, I plug that in for y. And this time when I do the math, I also get a true statement. I end up with 4 equals 4. And so this point is a solution as well. So equations with two variables have more than one solution. They actually have lots of solutions, lots of different ordered pairs that work when you plug them in or give you a true statement when you plug them in. And in fact, if we know part of a solution, we can find the other part of that ordered pair. So in example 3, we are given another equation, y equals 3x plus 4. And we're asked to complete the table of values so all points are solutions to the equation. What we can do in this problem is we can plug in the numbers that are given to us to find the missing number. So the first part of this table of values is saying x equals 0. And so I'm going to take my equation and I am going to replace the x with 0 and then see what I get. If x is 0, I end up getting just 0 equals 4 or y equals 4. That tells me that the point 0, 4 is a solution to this equation. I can do the same thing with x equal 2. I can plug that into my equation. If I replace the x with 2, I end up getting 6 plus 4, or 10. So the point 2, 10 is another solution. If x is negative 1, we get y equals negative 3 plus 4, or y equals 1. So there's my third solution. And then finally, in the last part, we're actually given a y value, but we could still plug in that y value and solve for x. If I replace the y value with 7, 7 equals 3x plus 4, this is now an equation that I can actually solve for x. I would subtract the 4 from both sides and then divide by 3, and that gives me x equal 1. So when x is 1, y is 7. In part B, I'm going to take those 4 solutions that I found in that table of values, and I can plot them on my coordinate system. So the first solution we found was x equals 0, y equals 4. The second one was x equals 2, so over 2 up to 10. If x is negative 1, we go up 1 to y equals 1. And if x is positive 1, I'm going to go up to 7 to y equals 7. The one thing I notice about these solutions is they happen to lie in a straight line. That's actually not a coincidence. Solutions to linear equations always lie in a straight line. That's really where that word linear comes from, because if you graph all the solutions, you end up getting a straight line. So graphing an equation with 2 variables is a great way of expressing what all the possible solutions are. The graph actually illustrates all the numbers that can be plugged into that equation and will give you a true statement. So in part 4, we're given an equation, we're not given any numbers, and we are asked to graph this equation. It should be a line by making a table of values. So what you can do is you can pick any numbers you want. I usually start with picking 0, 1, and 2 for x, but you can pick any numbers you want. And then I'm going to plug those into my equation to find the equivalent y values. If x is 0, I end up getting y equals negative 3. If I plug in 1 for x, I get 2 minus 3, or y equals negative 1. And if I plug in 2 for x, I end up getting y equals 4 minus 3, or y equals positive 1. I like to include always 3 points in my table of values, and this is in fact what I'll be asking you to do on exams. And so now I'm going to plot these points. X is 0, y is negative 3, x is 1, y is negative 1, and x is 2, y is positive 2. If I have done my math correctly, these points should lie in a straight line. If they don't, it means I probably made a mistake somewhere along the way. Now, to finish, we actually want to graph all of the solutions. And so to finish this problem, I am going to connect the dots. And this line that I have just graphed gives me all of the solutions to this equation. Every single point on this line is another solution to the equation. Let's do one more example together. I'm going to start by trying to make my table of values the same way. I can always make some changes if I struggle with these numbers. So if I plug in 0 for x, I end up with the equation 3y equals 6. I divide by 3, I get y equals 2. If I plug in 1 for x, I would have to then add the 1, divide by 3, and I get y equals 7/3. Now, there's nothing wrong with this solution. This is a point on the graph, but sometimes it can be kind of a pain to graph fractions. It can be difficult to actually make an accurate graph. And so what I think I'm going to do here is actually change the numbers that I pick. I'm going to erase this and pick some different numbers so that the math works out a little bit more nicely. You don't have to do this, but I think this really helps a lot. Noticing that I'm going to have to divide by 3, I'm going to pick numbers like 3 and 6, and hopefully that will help me avoid fractions. So let's see if that works. If I plug in 3 for x, I would add the 3, so 3y is 9, divide by 3, y equals 3. If I plug in 6 for x, I would add the 6 to get 3y equals 12, divide by 3 to get y equals 4. And so now I'm going to plot these points. X is 0, y is 2, 3, 3, and 6, 4. And once again, they lie in a straight line. That's a good thing. That has to happen. And so I can connect the dots And there is the graph of all of these solutions. Now the next thing I'm going to do is give you a couple of definitions, and I'll write those down in a minute, but while I have this graph on the screen, we have words for the places where the graph crosses the y-axis and the place where the graph crosses the x-axis. These are called intercepts. The x-intercept is a place where the graph crosses the x-axis. This is also a place where the y value equals 0. If y equals 0, you are on that x-axis. The y-intercept is where the graph crosses the y-axis, and if you are on that y-axis, that means the x value is 0. So if we want to find the intercepts of a line, we actually have to plug in zeros. To find the intercepts of a line, we can make a table of values, but we're going to pick 0 for x and 0 for y. When x equals 0, we're at the y-intercept. When y equals 0, we're at the x-intercept. So to find the y-intercept, I am going to replace x with 0 and then solve for y. In this case, I'm left with the equation negative 4y equals 12. If I divide by negative 4, I'm left with y equals negative 3. To find the x-intercept, I do something similar, except now I replace the y value with 0. So that gives me the equation 3x equals 12. I divide by 3, so x equals 4. So my y-intercept is the point 0, negative 3. My x-intercept is the point 4, 0. We can do the exact same thing in example B. It's okay that this problem has a fraction in it. That's why I chose the second example. So to find the y-intercept, I have to plug in 0 for x. Oh, and I just end up with 0 plus 3, or 3. So my y-intercept is at 3. For my x-intercept, I'm going to plug in 0 for y, and then I'm going to try to solve for x. You could clear the fractions by multiplying everything by 2, that's the LCD. Or in this case, you could just get the x by itself by subtracting the 3. And then if you have a 1/2 times x, to get rid of that 1/2, you could multiply both sides by 2. So negative 6 equals 1x. X-intercepts are often a great way to create a graph. If I'm asked to graph a line, sometimes I start by finding the x and the y-intercept, and then I pick my third point just by picking a random number for x. The last thing I want to do in this lesson is define some special cases, and that would be horizontal and vertical lines. So visually, this is what a horizontal line would look like. It's parallel to the x-axis. The equation of a horizontal line is always of the form y equals some number. Because when you have a horizontal line, the y values are constant and the x values can be anything. A vertical line would look something like this. It would be parallel to the y-axis. And when you have a vertical line, it's the x values that are constant. So your equation would be x equal number. And the y values can be anything. We'll talk more about these horizontal and vertical lines a little bit later, but for now, I want you to know how to graph these lines. So x equal 2, if you remember that this is a vertical line because it's an x equal, you can actually go ahead and just draw the graph right away. But the great thing is if you don't remember, you can make your table of values. Now this is kind of a special equation in that it doesn't have a y. And so how you make the table of values is the x's are always 2's. That's what this equation is telling me. And the y's can be any number you want. So you can pick any number you want for y. The x's are always 2. And so if we plot these points, x is 2, y is 1, x is 2, y is 2, x is 2, y equals 3, I can visually see that I have a vertical line. I have a vertical line with an x value of 2. The same concept holds for horizontal lines. If the equation just has a y in it and doesn't have an x, then you have a horizontal line. If you happen to remember this, you can draw the graph right away. You would go to y equals negative 1 and draw a horizontal line. But if you don't remember this, you can make a table of values, and the y's are always going to be negative 1. The x's can be any number you want. The y's are always negative 1. And if I go through and plot these points, 1, negative 1, 2, negative 1, 3, negative 1, I can then visually see that, yes, this is a horizontal line.